We're learning new details about one of those deadly U.S. strikes on alleged drug boats in the Caribbean. Sources tell CNN the U.S. military carried out a follow-up strike on September 2nd after becoming aware of survivors in the water.
The Caribbean Sea was quiet at 9:58 this morning. Deceptively calm. Miles of blue water stretching toward the horizon, unmarked by the violence about to unfold beneath its surface. But above that silence, an AH-1Z Viper attack helicopter lifted from the deck of the USS Gerald R. Ford, its rotors cutting through salt air with deadly precision. This was not a patrol. This was a hunt. Far below, racing through international waters at breakneck speed, a Venezuelan go-fast boat believed it had found freedom in the vastness of the open ocean. The crew pushed their engines beyond safe limits, throwing spray high into the air as they carved a northbound path through what they thought was empty sea. They had no idea they were already being watched. They couldn't see the sensors tracking them from 20,000 feet above. And they never heard the Poseidon aircraft that had marked their heat signature long before the Viper ever appeared on the horizon. This is the story of 8 seconds that changed everything. 8 seconds that proved speed means nothing when you're facing American precision. 8 seconds that sent a message echoing across every cartel network operating in these waters. If you want to understand how the United States maintains control over the maritime highways that feed drugs into our communities, you need to see what happened next. The real hunt began miles above the waves, where a U.S. Navy P-8A Poseidon surveillance aircraft swept the Caribbean with sensors more advanced than most people can imagine. Through thermal imaging systems that can detect the heat signature of a human body from extraordinary distances, the crew identified something that didn't belong. 2 high-powered outboard engines burning hot as they pushed a small vessel at over 45 knots in a perfectly straight line toward the north. That kind of speed, that kind of trajectory, and that kind of heat pattern rarely belongs to anything innocent on these waters. The Caribbean Express route has become a superhighway for narcotics trafficking, and experienced operators know the signs. The Poseidon crew locked onto the thermal plume trailing behind the vessel, then fed those coordinates directly into the Navy's secure data network. Every few seconds, new information updated the track until the system built a complete picture of the boat's movement. This wasn't guesswork anymore. This was mathematical certainty. Maritime interdiction operates on precise calculations. When you can predict exactly where a target will be in 5 minutes, 10 minutes, or 20 minutes, you stop chasing and start intercepting. The Viper helicopter didn't need to see the smuggler boat to begin planning its approach. The digital track file provided heading, speed, and projected position with surgical accuracy, allowing the aircrew to shape their attack geometry long before they came within visual range. 18 nautical miles became the critical threshold. At this distance, the helicopter entered what military aviators call the engagement envelope. The smuggler boat remained completely unaware of the aircraft above, but American systems already had everything they needed. Range calculations, drift patterns, wake analysis, engine rhythms. Every piece of data fed into a targeting solution that grew more precise with each passing second. The Viper dropped into a low-altitude approach, skimming just above the wave tops to stay below the visual horizon of the target vessel. Flying this close to the water served dual purposes. It kept the helicopter hidden from the smugglers while masking the aircraft's profile against the sun's glare on the sea surface. The crew wasn't simply chasing their target. They were stalking it with the patience of apex predators who know their prey has nowhere to run. From high above, the Poseidon continued feeding updates through encrypted channels, turning every meter of the boat's movement into actionable intelligence. The helicopter's flight path wasn't a straight pursuit line. It was an engineered intercept course, angled to cut off the vessel's projected path rather than trail behind it. This is the essence of attack geometry. You don't chase your target where it's been. You go where it's going to be. While the smuggler boat maintained its desperate sprint northward, believing raw speed would carry it to safety, the Viper was constructing an invisible cage around it. The Poseidon held the high ground with its sensors. The helicopter crept in from below the horizon, and the target vessel, still committed to its straight-line escape route, unknowingly held the exact heading the Americans needed for a clean strike solution. Every choice the aircrew made carried consequences that could determine the outcome. Flying low provided better concealment but left almost no margin for error. Flying wide offered more safety, but risked giving the smugglers time to accelerate or change course. These competing pressures forced the crew toward the more aggressive option, the one that favored stealth, speed, and precision over comfort. Because when your target still has no idea it's been found, the smallest tactical advantage can determine how the next few minutes unfold. Inside the Viper's cockpit, technology transformed human intent into mechanical precision. The pilot activated the helmet-mounted target sight system, a device that turns head movement into sensor direction, pairing it with the helicopter's forward-looking infrared camera. The two systems merged their feeds into a single stream of thermal imagery that revealed the smuggler boat as a bright signature cutting through cooler water. Even from this distance, the heat plume stood out like a highway flare against black asphalt. The numbers on the cockpit display updated with relentless urgency. Closure rate climbing past 190 knots, range shrinking every few seconds. The boat's heading matched perfectly with predictions from the Poseidon, confirming that the Americans weren't chasing electronic ghosts, but a real fast-moving contact that had remained on its northbound track far longer than most smugglers would dare. Meanwhile, aboard the USS Gerald R. Ford, radar operators maintained their own surveillance picture. Their role wasn't to control the engagement directly, but to build what naval crews call situational awareness. By holding a stable radar track, the ship helped ensure that both the helicopter and the Poseidon shared the same unified understanding of the target's behavior. This coordination created what intelligence analysts describe as a soft barrier. It gave the aircrew confidence that no unexpected vessels were closing from other directions, and confirmed that the smuggler boat was committed to its route. With surface and airborne sensors overlapping their coverage, the Viper had entered a corridor of certainty, a place where every second of movement could be measured, projected, and acted upon. Despite that certainty, the helicopter crew maintained tactical restraint. The pilot didn't activate a hard weapons lock. Instead, the aircraft angled its sensors toward the vessel, building visual and thermal awareness without crossing into actions that could be interpreted as escalation. This technique is known as deterrence through visibility, showing capability without revealing full intent. The message was subtle but unmistakable. If the smuggler boat attempted to enter restricted shipping lanes or tried to close distance with American naval vessels, the aircraft was prepared to respond. But the crew of the boat showed no signs of backing down. In fact, their behavior became increasingly telling. The vessel began executing sharp evasive maneuvers, 45-degree turns every 30 seconds, the kind of aggressive, abbreviated movements used only by experienced operators who understand the threats tracking them from above. This pattern represented a classic smuggling tactic designed to confuse predictive tracking systems and throw off aircraft trying to establish steady aim points. For small, fast vessels, these turns can buy precious seconds of confusion. This time, they bought nothing at all. The thermal imaging system and target sight combination filtered out the boat's sudden directional changes with mechanical indifference, recalculating the shifts almost as quickly as they occurred. Each evasive turn only revealed more about the crew's intentions and experience level. They weren't scanning for radio frequencies or reducing throttle. They weren't adjusting for weather conditions or steering toward any legitimate port. They were running with full commitment to escape, and they understood exactly what kind of threat was closing in on them. All indicators pointed toward one inescapable conclusion. The target had no intention of stopping voluntarily. They were prepared to push their engines beyond safe operating limits, test their luck against overwhelming odds, and challenge the reach of American maritime enforcement in hopes of slipping through what they believed was still possible. With every new maneuver, the Viper drew closer to the moment when observation would transition into action. The final phase arrived with startling speed. When the range narrowed to approximately 3.5 miles, the Hellfire missile mounted on the helicopter's wing pylon transitioned into its armed configuration. Inside the aircraft's digital systems, several critical processes activated in rapid succession that would have been invisible to outside observers but represented the difference between surveillance and strike capability. The missile's infrared seeker head began its cooling sequence, dropping internal temperatures to nearly 200 degrees below zero to maximize thermal sensitivity. Simultaneously, the guidance package's ring laser gyroscope spun up to 40,000 revolutions per minute, stabilizing the internal navigation system so the weapon could withstand the violent acceleration that would follow within seconds. The helicopter had crossed from pursuit geometry into what military doctrine defines as the engagement envelope. With the missile prepared for launch, the pilot selected lock-on before launch mode, a configuration preferred when atmospheric conditions are clear and laser designation remains stable. This choice allowed the Viper to establish the weapon's guidance solution before the Hellfire ever separated from its mounting rail. The second critical selection involved attack profile. Instead of programming the missile for a high-arc trajectory designed to defeat armored targets, the pilot chose direct attack mode. The weapon would follow a flatter path, rising only enough to correct its angle before diving toward the waterline of the target vessel. This targeting decision carried specific tactical reasoning. Fast boats are constructed from lightweight fiberglass designed to skip across wave surfaces at extreme speeds, but the material cannot withstand explosive pressure waves. By directing the Hellfire into the junction where hull meets water, The pilot ensured that the blast would tear open the vessel's bottom structure and allow the ocean to complete what the warhead initiated. Against small, unarmored craft operating at high speed, this represents the most efficient method of interdiction. Not through spectacular destruction of the superstructure, but by compromising hull integrity and letting physics handle the rest. Throughout this weapons preparation sequence, the helicopter's laser designator maintained constant focus on the target despite the boat's continued rocking motion and sharp, evasive turns. The turret's stabilization system absorbed the vibrations and movements of the aircraft's own flight profile, converting what could have been an unstable targeting process into a steady, unwavering guidance beam. Every second, the laser remained locked, translated into improved predictive tracking data for the missile's onboard computer. Meanwhile, the USS Gerald R. Ford and the high-altitude Poseidon continued feeding information into the shared tactical picture. The destroyer's surface radar confirmed the boat's speed and heading from sea level perspective, while the surveillance aircraft verified thermal signature and movement patterns from above. This multi-angle coverage eliminated ambiguity from the engagement. The Americans weren't relying on single-source intelligence, and they weren't making hasty judgments based on incomplete information. They had constructed a unified multi-sensor image of the vessel's behavior, construction characteristics, and compliance status. This represented what operational commanders refer to as the decision point, the narrow window where identification, legal authority, and threat assessment converge into actionable intelligence. The target had demonstrated consistent non-compliance. It had executed textbook evasive maneuvers. It had maintained prohibited speeds on a known trafficking corridor, and it was operating in international waters where United States enforcement authority was clearly established. With all conditions satisfied, the engagement moved from uncertainty into execution phase. The Viper maintained steady flight parameters. The missile remained armed and ready. The targeting geometry was locked and confirmed. Only one step remained in the sequence. When the pilot committed to weapon release, the helicopter's airframe absorbed a brief mechanical shudder, the kind that signals ordnance transitioning from standby to launch configuration. Then, with almost no audible warning, the Hellfire separated from its rail mounting. The rocket motor ignited instantly, accelerating the weapon forward with nearly 20 times the force of gravity. Within seconds, the missile crossed through the sound barrier and accelerated into supersonic flight, moving faster than the smuggler boat's crew could perceive or react to. The weapon's exhaust trail disappeared into sea haze as it pulled toward its programmed flight path, following guidance commands that updated thousands of times per second. Once airborne, the Hellfire executed the maneuver sequence its design was optimized for. A climb and dive profile that lifted it above the boat's line of sight before angling downward into terminal attack geometry. This trajectory allowed the guidance system to compensate for the vessel's erratic movements, smoothing out the target's zigzag course and calculating precisely where the hull would be at moment of impact. Segged. From external observation, the missile appeared as a small streak of fire against the blue sky. Inside its computer systems, however, thousands of mathematical calculations were processing every fraction of a second, adjusting pitch and roll angles to match laser energy reflecting off the target's surface. As the weapon reached the termination point of its dive sequence, the waterline became the focal convergence. This junction where fiberglass construction met ocean surface represented the structural weak point of a vessel built for speed rather than survivability. 8 seconds. That's all it took to turn a high-speed chase into scattered debris, floating on Caribbean waves. When the Hellfire found its mark, the explosion didn't just destroy a smuggler vessel. It sent shockwaves through every cartel network that believes speed and distance can defeat American reach. This engagement proved that the ocean offers no sanctuary when precision meets determination. The message is clear, and it's spreading across these waters. The United States doesn't just patrol the maritime highways that feed poison into our communities. We control them.